Okay. Now we'll go for some other one. So this is a matrix. We are going to find out the rank of this matrix. Okay. So this column elements can be written in terms of 1 multiplied by this column plus 2 multiplied by this column plus 0 multiplied by this column minus 1 multiplied by this column will give you 0. 2 multiplied by 1 multiplied by this column plus 2 multiplied by this column plus 0 multiplied by this column minus multiplied by this column will give you 0. Is it okay? So rank of a matrix is surely it not be, because this is 0. So rank of a matrix will not be 4. It will be less than 4. Correct? See, I repeat. See, what is the answer? 4, 2 5s are 10. So 10 plus 4 plus 0, see, minus 14. So answer is 0. For the rest of the number also it will become 0. Okay, so we can obtain this. So do some operation, we can obtain this. And this is linearly dependent column vector. I repeat, see, 1 multiplied by 4 plus 2 multiplied by 5 plus 0 multiplied by 2 will give you 14. Similarly, all the other elements. So we can have some operation, we will get C4. C4 is the same. Okay, 1 multiplied by C1 plus 2 multiplied by C2 plus 0 multiplied by C3 will give you C4. So this is linearly dependent column vectors. So rank will be less than 4. Rank will be less than 4. It will not be 4. Now you just take 3 by 3. So you just take 4, 5, 2, 3, 9, 6, 8, 10, 7. See, the answer exists. Determinant exists. So rank is 3. Find the rank of this matrix. 1, 4, 5, 2, 6, 8, 3, 7, 22. So rank of matrix must be 3, 2, 1. It can be 3 or 2, 1. We will see. Now do the operation. This operation. R2 becomes R2 minus 2R1. This is one operation. Second operation is R3 equals R3 minus 3R1. Do the operation of this matrix. You will get this. R2 minus 2R1. You multiply this by 2 minus R2 minus 2R1. So multiply this one by 2. So 2 minus 2. Answer is 0. Similarly, you can do the next one. You can do the next one. Do the operation R3 minus 3R1. You will get this. You just pull 2 out here. 2 in terms of R2 here. You just pull 2 out. So that will give you, that's minus 2 out. So that will give you 1, 1. So 1, 4, 5, 0, 1, 1, 0, 5, 7. Now this is the matrix that we have obtained. Okay. And you go with this operation R3 plus 5R2. R3 plus R3 becomes R3 plus 5R2. So 5 multiplied by R2 plus this one. 5 multiplied by R2 plus this one. You have to write here. So this will become 0. 5 multiplied by 1 plus minus 5 will be 0. 5 multiplied by 1 plus 7 will be 12. So this is your, what is this one? Echelon. What is this one? Pivot. Okay, Gauss elimination method. So this becomes 1, 4, 5, 0, 1, 1, 0, 0, 12. Determinant will be answer as 12, which is not equal to 0. So rank of a matrix is 3. So as we said, the rank of a matrix is number of non-zero rows or non-zero columns, doesn't matter. So A is given as this. Okay, A is given as this. So immediately you can say, that rank of a matrix is 2. Immediately you can say. See, this becomes 0. Everything is 0. You have to go only with this, either this 2 multiplied by 1. This will be 0. So answer exists. See, you just take this minus, answer is 0. You just take this, answer is 0. You just take this, answer exists. Take this minor. 2, 5, 0, 1. Take the minor. Answer exists. So rank of the matrix is 2. complex matrix. So we already discussed about complex matrix earlier. Just have the complex number. I becomes minus I becomes plus I. So that's all. So if all the elements of a matrix are real numbers, then it is called a real matrix. So we know already this. So for any complex number, for example, there exists some element having complex number like 2 plus IA, 0 minus 5i, 3 minus I, 4 plus 2i. So it's complex matrix. What we call this is a complex matrix. Conjugate of a matrix. You are going to take the complex conjugate. Okay, for example, just take 2 plus 3i. And what is the complex conjugate of this? 2 minus 3i. So I becomes minus I. 6 minus 4i becomes 6 plus 4i. 7 as it is, it will be there. 7. 2 minus 3i becomes 2 plus 3i. So minus I becomes plus I. That will be helpful for adjoint of the matrix. It's also very important property. Okay, adjoint of a matrix. Adjoint of a matrix is nothing but the transpose of the cofactor of the given matrix. It's nothing but adjoint of the matrix. Transpose of the cofactor of the given matrix is nothing but adjoint of the matrix. So we have to do two operations. One is transpose. Another is we have to find out the cofactor. Transpose of the cofactor of the given matrix. We'll find out what is the cofactor now. For example, just take A matrices like this. A equals 1, 2, minus 3, 4. What is the cofactor of this matrix? Listen to me. Here you have how to find out the cofactor. You just have do like this. The remaining one is 4. You write 4 here. So the cofactor of 1 is nothing but 4. Is it okay? Simple idea. I repeat. See here, you do like this. The cofactor of 1 is nothing but 4. You write 4 here. For the next one, you have to write with a negative sign. The cofactor of 2 will be minus 3. As I said, negative sign. So that will be plus 3. For this operation, you have to go with negative sign. For the cofactor of minus 3 will be 2. With a negative sign, answer will be minus 2. The cofactor of this one will be 1. See, leave it. Leave this number 1. So, in a matrix, to find out the cofactor, the symbol is plus, minus, plus, minus. Plus, minus, plus, minus. So, you have plus here, it will be minus. Suppose if 3 by 3 matrix, that will be plus, minus, plus, goes on. So, it is plus, minus, goes on. So, this is the idea of cofactor. Okay, what is the adjoint? The transpose of the cofactor. That is nothing but your adjoint. So, adjoint A is nothing but transpose of the cofactor. Is it okay? Transpose of a cofactor. See, for example, you find out A, 1, 2, minus 3, 4. We will find out first determinant A. Determinant A is nothing but 10. Suppose if it is equal to 0, it's a non-singular matrix. Okay, we will find out. We will see. First, we will find out adjoint. What is the adjoint of CT? This is 4 minus 2, 3, 1. We have already known. So, this becomes A adj A. This is your A adj A. You multiply this one will give you 10, 0, 0, 10, which is nothing but the property goes like this. A adj A, which is equal to adj A, which is nothing but your I. So, you will get 10. You can also do it on the other way around. Adj A. Do it on the other way around. You will get the same answer. Now, very important property. We can use this adjoint matrix to find out the inversion of the matrix. So, this is used. A inverse, which is equal to A inverse A, which is equal to I. And A adj A, already we discussed. A adj A, which is equal to adj A inverse. See here, we combine these two. So, A inverse, which is equal to adj A by determinant A. So, this is the formula for A inverse. A inverse equals adj A divided by determinant. So, to find out the inverse of the matrix, first you will have to find out the determinant of the matrix. Then adj A. What is adj A? Transpose of the cofactor. You will have to take the cofactor, then transpose. Divided by A determinant will give you A inverse. We will find a simple problem. So, A is given as this. So, what is the determinant of this A? It's nothing but 10. So, 1 by 10, 1 by A determinant. What are the cofactor? Transpose of a cofactor is nothing but 4 minus 2, 3, 1. You multiply these two, that will give you this matrix. This is nothing but A inverse. A inverse of a matrix. A inverse multiplied by A will give you I. To check whether we have found out the correct answer or not, we can check it. See? A inverse or A inverse, that will give you I. We'll check. A inverse. What is A? A is here. What is A inverse? Is here. You multiply these two, you will get 1, 0, 0, 1. It is nothing but I. Or otherwise you go with A inverse A. So A inverse is here. A is here. Multiply the matrix multiplication, you will get I. Okay. Simple problem. Now we will find out adjoint of the matrix. A equals 1, 2, 3, 1, 3, 4, 1, 4, 3. So it's a 3 by 3 matrix. First we will have to find out the cofactor of the matrix. First we will. The cofactor of this matrix is nothing but first one. This is A11. This is A12. This is A13. What is this one? A21. What is this one? A22. This is A23. This is A31. A32. A33. So you should find out the identification. Now you go for the cofactor of 1, which is nothing but A11. So you have to do operation 3, 4, 4, 3. Take the determinant. Answer is minus 7. So instead of this, you have to write minus 7. Is it okay? Now next one, A12. A12 is nothing but, you just have to 1, 4, 1, 3. 1, 4, 1, 3. Take the determinant. It must be minus 3 minus 4, which is equal to 1. You have to use, for the cofactor, you have to use minus sign. You have to use minus sign. Don't forget. As I told you, this will be plus. This will be minus. For taking the cofactor, don't forget. This will be plus. This is minus. This is plus. So alternately it goes. So this becomes minus 1. The cofactor of this will be minus 1. Don't forget. Now we will go for A13, which is equal to A13. So 1, 3, 1, 4. 1, 3, 1, 4. 4 minus 3, which is equal to 1. The cofactor of 3 will be 1. Is it okay? Similarly, you can do all the operations. We have found out now A21, A22, A23, A31, A32, A33, and all those things. Now you are going to substitute. Substitute. See, minus 7, as I said. Minus 7. Okay, next one will be A12. Oh, minus 1 is missing. So there may be a mistake. Okay, next one. Now we have written already minus sign here. See, here already one minus sign exists. Is it okay? Answer is correct. See, here already one minus, we have written one minus sign. This is your determinant. Minus sign exists here. Here it is plus, here it is plus, here it is minus. See here. So answer is correct. This answer is correct. Minus 7, 1, 1, 6, 0, minus 2, minus 1, minus 1, 1. So your Adj is this one. You have to take the transpose. That is your Adj. Okay, we have found out only cofactor. Now this is your Adj. So this is the adjoint of the matrix. Now find the adjoint of the matrix. A is given as this. We are going to find out. As usual, same procedure. You will have to find out now A11. See, A11 is nothing but 0467. 0467, which is equal to minus 24. Correct? So next one is A21. So sorry, A12. So minus sign exists. Minus sign already we written minus sign. The answer is minus 27. So instead of 2, you will have to write minus 27. So instead of 3, you will have to write. It is not here. So 5026. That is A13 is not here. A13 is somewhere here. It's not here. Okay. Okay. So similarly, you can do all the other cofactor operations, and we have written here. Minus 24, minus 27, 30, 4, 1, minus 2, 8, 11, minus 10. Take the transpose will give you this answer. So this is your Adj. Now inverse of a matrix. Inverse of a matrix is nothing but Adj divided by determinant. So this is where we are going to find out for inverse of matrices. Okay. So now take the determinant. If determinant equal to 0, we can't find out the inverse of the matrix. That is the first idea. If determinant equal to 0, divide by 0 is, that will give you infinity value. So which we can't find out. So if determinant equal to 0, A inverse doesn't exist. First you have to check with whether determinant is 0 or not. So first determinant, answer determinant minus 25. So A inverse, if it is equal to 0, A inverse exists. So this is minus 25. Now you go for edge. You know how to take edge earlier. You have already did for taking cofactor and transpose, which is nothing but our edge A. So this you have to take this one, 1 multiplied minus 1, 2 multiplied by 2 with a minus sign, that will give you minus 5. So this is your minus 5. Okay. So similarly, and you have to take the cofactor, this multiplied with this multiplied with this, that will be written here. Okay. So we have found out now edge A, cofactor transpose, that will give you edge A. We have found out edge A. Edge A divided by determinant of A will give you this. Edge A, this is transpose of a cofactor divided by determinant A. So that will give you this matrix. Now you pull 5 out, common out everywhere. So that will give you 1 minus 1 5. Here also you can pull out. Here also you can pull out. So that will give you 1 by 5, this answer. 1 by 5 you just multiply, that will give you this answer. So this is A inverse. Okay, very simple idea. Find the inverse of this matrix. First you will have to go only with the determinant. A determinant exists. If it is equal to 0, A inverse will not exist. So here A inverse exists because determinant A equals minus 2. Find out the cofactor. So C11, the cofactor will be this multiplied with this minus this multiplied with this. So cofactor is this one, minus 1. Cofactor of C21 is this one. Cofactor of C31 is this one. So we have found out all the cofactors. Put it in the matrix. Put it in the matrix. Take the transpose. Transpose divided by, that will give you edge A divided by determinant A will give you inverse of a matrix. So this is your inverse of a matrix. How to check inverse of a matrix? Whether it is correct or not. Inverse of a matrix multiplied by A matrix will give you I. This multiplied by A will give you I. Okay, if you want to check whether your answer is correct or not, this way only. Simple. So last slide, the result can be checking by using, as I said just now, A inverse which is equal to A inverse A which is equal to I. The determinant of the matrix must not be 0 for the inverse to exist, as there will be no solution at all. So non-singular matrices have non-zero determinants, singular matrices have 0 determinants. So if determinant is equal to 0, what we call this as singular matrix. For A inverse to exist, whether we can have singular matrix or non-singular matrix. See, A inverse should exist. For example, you want to find out the matrix A inverse. You have to find out the inverse of a matrix. You are going to go with this or this. It must be a non-singular matrix. Very good. It must be a non-singular matrix. Singular matrix will have determinant equal to 0. Okay. So we will stop today. We will see in the next class. Okay. Bye, students.